This is the third example of a linear equation of the form ax plus by equals c, where a, b, and c are integers, and this time it's negative 7x plus 5y equals 6. In my previous video, I found the intercepts. Quick reminder. To find y-intercept, I have to let x to be equal to 0, plug it into equation, and solve the equation for y. So I can see my y-intercept is 0, 6/5. To find x-intercept, I need to let y to be equal to 0, plug it into equation, and solve the equation for x. So my x-intercept is negative 6/7, 0. And I could use this intercepts to graph the equation. However, as I mentioned in my previous video, if I want to maximize the accuracy and precision of my graph, I should use ordered pair solutions with integer coordinates. So what is the fastest and easiest way to find an integer ordered pair solution? Step number 1, solve the equation for y. Okay, let's try. Negative 7x plus 5y equals 6. First step, move negative 7x to the other side. It's going to become positive 7x. So 5y is equal to 7x plus 6. Divide both sides by 5. Y equals 7x plus 6 over 5. Now, if I divide each term in my numerator by the denominator, I'm going to get 7/5 x plus 6/5. And you probably recognized it as a slope-intercept form, where 7/5 is the slope and 6/5 is the y-intercept, which we already found. Step number 2, hunt for point with integer coordinates. For hunt, I'm going to use this form of my equation. In this form, I'm going to plug different integer values of x, plus minus 1, plus minus 2, plus minus 3, until I find a number that would turn my numerator into a number divisible by my denominator. In my denominator, I have 5, so I want my numerator to be divisible by 5. Let's start. X equals 1. Y equals 7 times 1 plus 6 over 5. 7 times 1 is 7. 7 plus 6 is equal to 13. 13 is not divisible by 5, so this is not working for me. And actually, I see that negative 1 is not going to work for me either. So I'm going to jump to x equals 2. Y equals 7 times 2 plus 6 over 5. 7 times 2 is 14. 14 plus 6 is 20. 20 is divisible by 5. So my y is equal to 4. And this is my first point with integer coordinates. Now for additional points, I'm not going to continue with my hunt. I'm going to use the slope. So my slope-intercept form, as we said, 7/5 x plus 6/5. So I can see that the slope is equal to 7/5 and the y-intercept is equal to 6/5. A few words about the slope and how I can use the slope for graphing. Slope is equal to the ratio of delta y over delta x, which is rise over run. So how can I use slope for graphing? If I have a graph of a line and I know the slope of that line, then on that line, if I have a point and I can choose any point, I can use y-intercept, I could use x-intercept, or I could use any point. Now from that point, if I start performing the steps described by my slope, what does it mean? If I move delta y units in a vertical direction and then delta x units in a horizontal direction, I will end up at the point on my line again. So that's going to be another point. Now, if I want more points, I can continue performing my steps. Delta y units in the vertical direction, delta x units in horizontal direction, and again, I'm going to end up at the point on the line. So this is what I'm going to use now to find my additional points. My slope is 7/5, as I said. Now 7/5 is a positive number presented as a ratio of two positive numbers. And I hope you remember that a positive number could be also presented as a ratio of two negative numbers. So I can write it as -7 over -5. So I believe I have everything in place for me to find additional points. Now, as I said before, for a starting point, I could use any point. I could use my y-intercept. However, my y-intercept has fraction coordinates. And if I plot a point whose coordinates are fractions, there's going to be an error. And then if I start making steps according to my slope, that error will propagate, and then the accuracy and precision of the graph is not going to be that great. So to maximize the accuracy and precision, I prefer to use as a starting point, a point with integer coordinates. And then for additional points, I will use the slope. So let's plot my first order pair solution with integer coordinates, and I'm going to call it starting point. Now from that point, I'm going to perform the steps according to this version of my slope, 7/5. So move 7 units up and 5 units to the right. So this is my additional point with coordinates 11, 7. However, that point is outside of the boundaries of my graphing paper. Then I will find additional points that would be within the boundaries of my graphing paper. For that, I'm going to use now this version of the slope, -7 over -5. So -7 means I would have to move 7 units down, and -5 means I would have to move 7 units to the left. So going back to my starting point, 2, 4, go 7 units down and 5 units to the left, and here is my new additional point with coordinates -3, -3. And then I will repeat my steps one more time, 7 units down, 5 units to the left. And here is another additional point with coordinates -8, -10. So I believe that now I have a sufficient number of points to graph my line. I'm going to connect it with a straight line, and here is my graph. So what steps we had to do to graph this equation? We solved the equation for y. We hunt for a starting point with integer coordinates, and for additional points, we use the slope. And to finish this series, I would like to offer you these 4 additional examples of linear equations of the form ax plus by equals c. And I would like to offer you to graph them using ordered pair solutions with integer coordinates, and find them, you can find them with the methods discussed in this video.